With our focus today, we are going to look at triangle similarity. And if you think back to last term, when we wanted to show that two triangles were congruent, we had a whole lot of ways of doing it. First of all, we had a method based on motion, where you could move one of them on top of each other using only the three rigid motions: reflections, rotations, translations. We saw in our last lesson that if you add dilations to this, you can change it from triangle congruence to triangle similarity. Additionally, when we were working with triangle congruence, we had a side-side-side theorem, side-angle-side, angle-side-angle, angle-angle-side, and hypotenuse leg. So we had a list of 5 theorems that you could use, each one of them is a checklist that says if you complete the checklist, we know that these two triangles are completely congruent. They're the same shape and the same size. Our focus today is on triangle similarity. Very, very similar in structure, but instead of having these 5 tools for triangle congruence, in order to get triangle similarity, we only have 3. Angle-angle, side-side-side, and side-angle-side. To avoid some potential confusion, because we had side-side-side earlier with congruence, we had side-angle-side with congruence, these are a different one. The conditions will be different. And so to distinguish between them, we will say side-angle-side similarity when we write down and reference this one, side-side-side similarity, and angle-angle similarity. That way we can reduce the confusion as to do we mean congruent or similar. And so we're starting off right here, using the angle-angle similarity postulate. This simply says our checklist comprises of 2 things. Angle-angle. We need to have a first pair of congruent angles and a second pair of congruent angles, which of course from the third angles theorem would tell us that we actually have all 3 pairs of angles congruent, but we won't need to write that down. As long as we can complete these checklists, we know that the triangles are similar. So, why are these similar? Well, angle A is congruent to angle D. They're both 90s. We know that all right angles are congruent. That's 1. Also, we have vertical angles here in the center. So I'm just going to label it angle 1 and angle 2 just to make it easier to write. Angle 1 is congruent to angle 2 because they're vertical. So we've got a second pair. There, we're done. We would have triangle ABC is similar to triangle A matched up with D, B matched up with E, C matched up with itself, corresponding. And we use angle-angle similarity to do it. We're done. If we are looking for an explanation or a justification, this is what we're searching for. If it asks us to prove, this is part of the details for a proof. Regardless, either way, you're still running through the thought process of searching out and completing our angle-angle checklist. So, why are these angles similar? And write up a similarity statement. Again, we can use angle-angle. Where do we get our first pair of congruent angles? And what are they? Angle B would be congruent to angle E because they're both right angles. course, 43 does not match 47. So we can't say A is congruent to F. They're not the same size. But we can keep in mind, what do all triangles for three angles add up to? 180. So if we are looking for the size of angle D, 180 subtract off 90 would give us 90. Subtract off the 47, and 90 subtract 47 gives you 43, so angle D has to be a 43-degree angle because of the triangle sum theorem. So we would have angle A congruent to angle D because those are both 43 degrees. There. We've got our checklist completed. This is enough for us to say, beyond doubt, we absolutely know that these two triangles are similar. So we'll write up our statement. Triangle ABC is similar to triangle, and let's find our corresponding parts. Angle A corresponded with angle D. Angle B corresponded with angle E, and C corresponded with F. And we used angle-angle similarity to do it. We're done. Now, this angle-angle similarity, if you can get it to work, is usually the easiest one to use. So, of course, this should be your first strategy. If you're trying to explain or show why triangles are similar, finding two pairs of matching angles is the way to go. It's not always going to work. What if you can't get two pairs of angles? What if you can only get one pair of angles? What if you can't get any pair of angles? There are still two other tools. The side-side-side similarity actually gives us a checklist of three things. Side, side, side. And side-side-side, when we were doing triangle congruence, said we need three pairs of equal length sides. Three pairs that were congruent. We don't have congruent here. We need three pairs with a matching scale factor. So if we were to create a scale factor using ABE matching up with DE, and I'm just going to completely make up a number. What if we got a scale factor of 4 from that one? In order to use side-side-side similarity, when we find the other two pairs of scale factors, they have to be the same. And so DF with AE, if we could get all three pairs of sides with the same scale factor, that will complete the side-side-side similarity theorem. And we have one other tool available as well. We have the side-angle-side similarity, which of course works very similar in structure. Side, angle, side. We would need one pair of congruent angles, two pairs with matching scale factors like we just looked at, having a scale factor of 4 matching a scale factor of 4. And then the last one, of course, we have to make certain that it actually does fit the side angle side order. Same way as when we were looking at triangle congruence, we had one pair of matching sides, a second pair of matching sides, and it was important for us to have the angle included in between be the angle that matches. If it's not the included in between angle, you do not have the side angle side order. Okay, so verify that the triangles are similar. Which one of our three theorems looks like it's going to be helpful? angle needs two pairs of angles. Will you be able to get two pairs of angles? No. Side uses one pair of angles. Can you get one pair of angles? No. Which forces us down to one. We have to use side similarity because we do not have the ability to get matching angles. So let's just calculate those scale factors. Find one pair of corresponding sides. Of course, base with base. SU and PR, 3 to 2. And if we were to divide that out, that's 1.5. Every single pair of sides has to match this 1.5 scale factor. And if it does, that's side. This is our first pair of sides. Check the second and the third. TS matches up with, okay, I'm looking at this as a rotation. If we were to spin it 180 degrees, QR would match up. So 4.5 divided by 3, which is also 1.5. 1.5 matches 1.5, so that's still good. Third pair then, TU and QP, exact same numbers. So there we go, we've got it. We would have triangle PQR similar to triangle STU by side similarity, and this is the work we would show to prove it. This is our work that puts down everything, completing our checklist. We know that these are similar. Okay, so let's consider another one. Verify these are similar. Which tool are we going to use? Which is the same thing as saying how many pairs of angles do you have? Right away we can see 70 matching 70. So that's one pair of angles right away. Can you get a second pair of angles? No. We're missing information. It looks like they're 90s, but we're not given any kind of information to be certain that we have 90s. So let's try out side, angle, side then. Side, angle, side, and verify that we've got the side, angle, side order. Okay, so we've got angle D congruent to angle H, because of course we already noted the tick arcs that they're both 70 degrees. That one's easy to get. Checking the side conditions, we need corresponding sides, so we can calculate the scale factors. DE would match up with JH. So DE and JH create a ratio of 2 to 1, which is just 2. Okay, as long as our next scale factor matches that scale factor of 2 that we just calculated. So DF and KH, those match up, 5.8 and 2.9. Of course, 5.8 divided by 2.9, you can put it in your calculator to verify. That actually is 2. So we've got it. Lastly, do they actually fit the side angle side order? The angle of 70 degrees was in between. It does fit that behavior. It is an included angle, so there we go. We would know angle triangle DEF is similar to triangle HJK by side angle side similarity. And I structured this one so that you could see just how this would look. This is how I would like to see your homework written up. You can give yourself a little bit of space at the top to write down your triangle similarity statement and your justification why. Of course, that could be just on one line. But then show me that you're completing the checklist. Show that you're checking all the criteria. All right, slightly more complex picture. Why would we have angle RSV similar to triangle RSV similar to triangle RTU? First of all, where are they? I want to make sure that we can see which triangles we're talking about. And I'm going to use a highlighter here. All right, we've got our two triangles, the one in the yellow and the overall big triangle. Why are they similar? Well, again, let's consider which one of our theorems is going to work. Are we going to use angle-angle? Are we going to use side-side-side? Or are we going to use side-angle-side? Which one works? I'm noticing the tick arcs giving me one pair of angles. So instantly I'm going to rule out side-side-side because I've already got one pair of angles given to me. Do you see another pair? They are sharing that angle R. Angle R is an angle in both the yellow triangle and the overall big one. Because of that, I've got two pairs of angles. I can use angle-angle similarity, and that's that. So I'd be able to write up triangle RSV is similar to triangle RTU by angle-angle similarity. And I can write up those details. Angle R is congruent to angle R. Angle RSV is congruent to angle RTU. Okay, there are my two angles showing that angle-angle similarity works. Now that we know that they are similar, we can combine our work using the similarity with our work from previously. Because they are similar, we know that we can set up a proportion and solve for missing side lengths. We would know that RS corresponds with RT. So 10 is going to match up with length RT. We would know SV corresponds with TU. So 8 would match 12. We can build a proportion based on those matching pieces, and of course we know how to solve these. I'm going to choose to cross multiply, so 8 times RT, 12 times 10 is 120. Dividing out by 8 tells us the total length RT is 15. And that's precisely what we were asked to do. Find the length of RT. We've got it. It's quite common in these types of problems that you will figure out, explain why they are similar first, and after you know that they are similar, that's what tells you you're allowed to set up a proportion like this. Setting up the proportion will allow you to then figure out and find an answer. Okay, similar type problem, and I'm changing the directions. I would like us to figure out what is the length WB, as well as verifying that we're allowed to do it. So first of all, why are these triangles similar? Vertical angles will give us one pair of congruent angles at that point X. Okay, so we've got our vertical angles. Checking the others, 15 is going to match up with 20 because 15 is the bigger one measurement on the left triangle, 20 is the bigger measurement on the right. So I can put down 20 over 15, which simplifies to 4 over 3. 16 and 12, we divide out by 4, we get 4 over 3. So I've got my pieces. Because of side-angle-side similarity, I know that these triangles are similar to each other. Because they are similar, now I'm allowed to set up a proportion. And so I'm looking at this 12 matches 9. Sorry, 12 and 9 are on the left triangle. They correspond. 12 corresponded with 16. 9 corresponded with WV. And so we can solve from here. 12 times WV. 9 times 16 will equal 144. And when you divide out by 12, you get an answer of 12. And we're done. Prove that these are similar. It's basically the same thing as what we were doing. The big characteristic here is that we were not given specific numbers on the triangle, on the triangles. However, I'm looking at these two pieces right here, and I'm going to observe some algebraic manipulation. If we were to divide both sides by 3, this becomes UT equals 5 times RT over 3. If we divide by RT, that cancels, giving us UT and RT with a scale factor 5 over 3. This algebraic manipulation allows us to go through and show UT, RT would have a scale factor 5 over 3. Okay, we've got one pair of scale factors. We, of course, have the angles because of vertical angles. Angle STR is congruent to angle UVW. Okay, STR would be VTU. And again, that's because vertical angles are congruent. Now we need another pair of sides. But we've got the same thing here. Using a similar algebraic manipulation as to what I had over on the right, if you do the same process with this equation, you will wind up getting VT over ST is equal to 5 over 3. The exact same work with different letters. And so there. We'd be able to write up triangle UVT is similar to triangle RST by side-angle-side similarity. This right here is our proof. use. Okay, a photo shows a gable-style roof. We have parallel, we have similarity, so find a length. Well, of course, we know that because they are parallel, that alone is enough to guarantee similarity. We know corresponding angles will be congruent. Right there, we've got angle, angle. So guaranteed, as soon as you've got parallel, you've got similar. And so our characteristic then is trying to figure out how will we set up the proportion. What are the matching or corresponding components? 6.5 would clearly correspond with 24. Okay, so 6.5 will match 24. What are another pair of matching parts? Okay, now we, of course, need to keep in mind what it is that we're trying to find. We're trying to figure out the length of BA. BA is the entire left-hand side. Since it's the entire side, it needs to go with the big triangle, not the small one. And of course, that means it's going to match up with the left-hand side of the small triangle, which is BF. Okay, so here's our problem then. We have two different unknown lengths. With two different unknown lengths, we've got to figure out how to fix this. Well, I'm going to start putting some variables into it, just so that we've got one letter to write down instead of 4 letters to write down. So this piece, length BF, I'm going to call just X. That would allow me to rewrite this as 6.5 over X. I could then make the observation that the entire side BA are those two chunks together, just using the segment addition postulate. And so BA will be the component 17 plus X. And now we've got it down to just one variable. This is a type that we can solve then with cross multiplying. 6.5 multiplied, that would be 6.5 times 17 plus X. And on the other end, 24 times X equals 24X. In order to solve this equation, one way to do it is to distribute across the parentheses. 6.5 times 17, which would equal 110.5. 6.5 times X would equal 6.5X equals 24. To combine our like terms, we'd have to subtract over 6.5X, which would take us to 110.5. And 24 subtract 6.5 equals 17.5. You divide that out. And 110.5 divided by 17.5. We can grab a calculator and crunch those numbers. So 110.5 divided by 17.5, approximately 6.3 when we round to the nearest 10. So there, we're done. This length X is 6.3 feet. Of course, we still have to answer the question, because the question was ultimately, how long is BA? 17 plus the 6.3 yields the final answer that it is 23.3 feet. And we are ultimately done. And thus we're done. Longer than normal video, trying to provide lots and lots of examples so you can see exactly how each one of our 3 similarity theorems actually work. These will be your primary tools when you are trying to figure out, are these 2 triangles similar, yes or no? These will be your go-to tools to figure it out. And if you can determine that, yes, the triangles actually are similar, only after you know they're similar, then you are allowed to set up the proportions and solve for side length.